Hi. As many of you perhaps know, there is an ambitious government-led plan to build a train loop in southeast Mexico, mainly over the Yucatan Peninsula, a Cenozoic Holocene carbonate platform with extensive karst processes going on. Its main geological features include an alignment of sinkholes forming an arc over the deeply buried Chicxulub crater, a number of peripheral small fractures associated to the impact, the whole bush fracture zone running north-south semi-parallel to the coastline, and in the lower eastern coast, the biggest underwater cave systems of the world, Sakatun and Oxbelha, each one with hundreds of kilometers of underwater passages already surveyed. Karstification is a geomorphological process which involves rock dissolution, exacerbated around groundwater flow paths, which in turn are determined by those tectonostratigraphic controls. Karst hazards that could have an impact on citizens and infrastructure include sinkholes, flooding, and groundwater contamination. Sinkholes, or dolines, are by far the largest and most frequently encountered karst features in this region. Their correct mapping and characterization are of great importance for a proper assessment of the possible occurrence of new events and the likely effects they could have on the anthropogenic environment. A section of the railroad will run along this 250 kilometers long highway. So the goal for this pandemic project was to develop a karst hazard assessment plan through a robust field exploration program to feed with reliable geological information to decision-making people and agency to aid in the development of engineering solutions to overcome these hazards and to permit development along the highway in a secure and sustainable way. In order to complete this task, as a preliminary approach, it was used a 1 square kilometer grid and a hazard score was calculated for each one of the grid cells. We use an equation that combines the value of areas with potential for karst development searched from the Mexican National Risk Atlas with values of sinkhole density. These scores were subsequently divided into four categories using the Jenks natural breaks classification scheme, which partitions data to minimize variation within each group while maximizing difference among groups. To make the hazard scores to work directly with a numerical exposure score for assessing risk, the following equation was used. The number 1 on the right side of the equation is added to keep the score always positive. Then the scores were normalized to 1 to create the index. The four hazard categories are low, moderate, high, and severe in ascending order of the scores. It's worth noting that there is no zero karst hazard score. It's always present. So now we have a working hazard zonation map as a starting point. With this preliminary assessment in hand, we proceeded to set direct and indirect sampling stations along the highway, spatially distributed accordingly to the hazard category, so denser distributions located in sections with higher hazard score. Methods include direct sampling, as core drilling, and in situ and laboratory tests for mechanical properties of rock, indirect geophysical methods such as seismic refraction tomography, multi-channel analysis of surface waves, and electrical resistivity tomographies. Here I'm quickly showing some examples of the first results coming in. We combine the results from the different methods, different exploration methods to build a geotechnical profile along the road. We are working on sections of 5 kilometers long. In a parallel way, in order to have a comprehensive understanding of the possible risk associated with sinkholes, it is essential to compile a detailed inventory, including the morphometric parameters of these karst landforms, to assess the likely risk during urban planning or episodes of subsidence. A high-resolution 20 centimeters digital terrain model derived from airborne light detection and ranging LiDAR data was used to perform semi-automated methodologies to refine doline identifications within a 500-meter band along the highway. As a preliminary of partial conclusions, I would say literature research and preliminary hazard zonation was used as a starting point to spatially distribute sampling sites to conduct a detailed geological and geophysical exploration program, allowing to perform a robust karst risk assessment useful for design, construction, operation, and management purposes along the highway. Thanks.